Well, this is odd. You're watching this on Monday the 14th of September, and a few hours ago, a team of astronomers here at Cardiff University announced to the world what could be the most significant astronomical find for decades. I'm filming this a few weeks before that announcement because the Sky at Night has been given exclusive access to the team behind the discovery. We're having to be incredibly secret. So what is this top secret, groundbreaking discovery? Well, if you haven't heard, the team claim that they found what could be the signs of life on Venus. I can't believe I get to say that to camera, but the team think they found what could be the signs of life on Venus. Welcome to the Sky at Night. Okay, here's what we know in a nutshell. The team used radio telescopes here on Earth to detect a gas called phosphine in the high atmosphere of Venus. On Earth, that gas is only made in factories or by bacteria in certain conditions. Either way, it's made by life. The team asked whether natural chemical processes could account for what they've seen on Venus, and the answer is no. They could only make about a 10,000th of the amount of phosphine seen. If that's right, then this detection of gas is a sign of life high amongst the clouds of Venus.
Which would be something of a shock, to say the least. Venus, our planetary neighbour, the third brightest object in the sky, named after the Roman goddess of love and beauty. But Venus turned out, on closer inspection, to be a complete hellhole. It was the first planet we sent a probe to, and since the 1960s, visiting spacecraft have revealed its true nature. With searing heat at the surface, hot enough to melt lead, super hurricane-forced winds, atmospheric pressures 90 times that of Earth, and clouds of sulfuric acid, it is the last place in the solar system you'd think to look for life.
This is the Physics and Astronomy department here in Cardiff, and I'm here to meet Jane Greaves, who led this exciting research. It's eerily quiet. It's the end of summer, and of course the university is just emerging from lockdown.
So here we are in the physics building.
Yeah, well, it's nice to come visit you.
It's difficult trying to maintain the distance in the circumstances.
Yeah. Well,
yes.
at least, has that been weird? I mean, it must be weird enough having this secret to yourself, but having a secret in lockdown seems particularly odd.
Sitting at home trying to think about the excitement of this, it has been very odd.
Well, Jane, thanks for telling us about this. It's incredibly exciting, but what on earth did you think you were doing? What gave you this idea?
Well, you know me, I've always wanted to do crazy science with the James Clerk Maxwell telescope. And I was looking around at what you could do for the solar system and found this molecule phosphine. And I found out that on Earth, phosphine is a biosignature gas.
And so a biosignature means something produced by life?
Yes, exactly. So in the case of phosphine, anaerobic bacteria put out phosphine as one of their waste products, essentially. And there's really no other way it occurs on Earth. So there's a major branch of literature I wasn't previously aware of about penguin crap, because penguins have these bacteria in their guts, and so they leave it behind them as they travel around in their little shuffling groups.
So one day, Jane walked into my office and introduced me to the project by asking me if I'd like to study penguin poo in the upper atmosphere of Venus.
One of the first members of the team Jane recruited was Emily Draybeck-Maunder.
So my response was yes, of course. We were trying to find a gas that would assess if there was the possibility for life in our solar system. So we were running into the problem that Yes, some gases could be used to indicate life, but they could also be produced in many other ways. So through natural chemistry in those in particular environments.
So like methane on Mars, for example, it might be biological, but it could equally be something else.
Yeah, absolutely. And so phosphine seemed to be our answer for a gas that was a biomarker that was produced by life, at least on the Earth, but it was more difficult to produce through natural chemical means.
While in Cardiff, I met up with an old friend of the Sky at Night, Chris North. Although not directly involved with this project, Chris is part of the same physics department and has been excitedly following the research. So Chris, one of the surprising things about this discovery is it's almost the wrong planet. If we're talking about life in the solar system, I would have expected to be sitting here talking about Mars.
Yeah, and I certainly thought that the first time, if ever, we talked about the detection of life elsewhere or the past life elsewhere would be on Mars. Venus, on the other hand, not a good place to look for life at all. And what's really interesting about this discovery is this is the first time we've got detection of a biosignature without any plausible other explanation that we can think of. There's the Sherlock Holmes quote that once you eliminate the impossible, whatever remains, however improbable, must be the truth. That's basically the scientific method.
Most astronomers, in search for life in the solar system, focus on Mars, or maybe the moons of Saturn. Jane, somewhat contrarily, chose to target the unfashionable hellhole that is Venus.
Why Venus in particular?
As we know, there was probably a runaway greenhouse effect on Venus hundreds of millions or even billions of years ago, and as a result of that, the surface is now incredibly hot. But the clouds, and this was realised, I think, in the 1960s by Carl Sagan, when you go really high up, so about 50 kilometres up, the pressure in the clouds is like it is at the surface of the Earth, and the temperature is actually like 20 or 30 centigrade, so it's really quite habitable. The thinking behind this is perhaps Venus was habitable much like the Earth, but a long time ago, billions of years ago. As this runaway greenhouse effect happened, some of the smaller life was able to float up into the sky, essentially, and survive and develop new ways of living up there.
So, we've got this idea that phosphine's being produced by life in the clouds of Venus. How long does it last in the atmosphere?
It's hours that it lasts. Before, on average, the molecules will be broken up.
So that means the fact we see it, if it's not a long-lived chemical, that means something's producing it now. This isn't a reservoir of phosphine that's been there for a long time.
Yes, something is producing it all the time to produce this much phosphine that we see.
Okay, so there's this speculation that there might be a place for life there. There's the idea that phosphine might be a sign of life, so go looking for it.
Yes, nobody has really looked for phosphine as a biosignature before, so my part of the story was thinking, well, why not look for it on another planet? And that's where JCMT came in.
The JCMT, or James Clerk Maxwell Telescope, is a radio telescope perched high on the Mauna Kea volcano in Hawaii, and was Jane's first port of call in her search for life on Venus.
When you write a telescope proposal that says, I want to look for life on Venus, was there a point where you thought it was absurd, and did people just treat it as a bit of a joke?
Nobody really laughed at it. They thought, this is a bit eccentric and there's probably better things to do with expensive telescope time.
I could be using that telescope time to look at galaxies.
And you love galaxies.
I love galaxies.
Yeah,
and there are lots
sort of feel it with the galaxies.
And there are lots of people like me who want to look at galaxies. But,
yes, there's more of you than people who want to look for aliens on Venus.
Using the JCMT to observe radio waves from Venus, Jane and Emily were able to hunt for the presence of phosphine.
So just talk us through how the observation works.
So what we're looking for is an absorption feature coming from phosphine. So light will be reflected off of Venus, and so we'll be able to see sunlight reflecting off the clouds of Venus.
And that counts for radio waves as well, right?
Absolutely, yes. But some amount of that light will be absorbed by different gases at different wavelengths.
It turns out phosphine absorbs at a very specific wavelength, around 1 millimetre, that other molecules don't, and JCMT was ideally set up to do this.
So the game is that you tune to that frequency, and you look for a dip in the radio signal that's coming from the background, from the planet, and,
Yes.
and if you see that dip, you think, right, that's phosphine.
That's exactly it.
Because people normally use this thing to look at star formation or distant galaxies or...
Exactly. And so looking at solar system objects, it was already going to be a challenge for this telescope. Venus is so bright that it can actually create reflections in the instrument.
There was so much of Venus's radio signal bouncing around the telescope, it caused us quite a lot of problems. It comes at you from bits of the telescope dome and the ground and all sorts of things that are hard to control.
Trying to find the signal in all of that noise is incredibly difficult. When we first looked at that data, we kind of lost hope that we could find phosphine. It took years and a lot of perseverance that Jane had.
Do you remember when you first thought that there might be something there?
Cambridge University gave me some money to go there for a few months to do collaborative science with them, which Venus was not really on the radar, so to speak, but because I had this nice time to sit in an office and do not my usual stuff, I thought, well, let's just have another go at this. And I realised actually there was something there, and that was like 18 months after we got the data.
At that point, were you saying, well, this could be life?
I did think, oh wow, perhaps there really are these floating microbes. So I think this was a crazy night. I knew I had to go shopping, and I thought, what's the British way to celebrate? Make a curry. So I was wandering around Sainsbury's in Cambridge looking for curry ingredients and thinking, okay, must not crash the car on the way home or anything like that. And thinking, like, I'm probably the only person in Cambridge Sainsbury's trying to find curry ingredients and wondering if they've discovered extraterrestrial life.
Astronomers have found weird things before and said maybe this might be a sign of life. In this case, obviously it's not definitive, but you said, okay, this is an experiment. If we find this, it might well be a biosignature. We'll look for it, and we found it. Like, that hasn't happened before, and I think that's really interesting that it was something you went looking for a biosignature and found.
Yeah, we'd done exactly what you're supposed to do in science. Predicted a thing, gone out and looked for the thing. The surprise was finding the thing. So we really wanted to make sure that this was robust, so we were at that point able to go and ask another telescope on the back of this if we could have a go and just do the same thing again, scientific method.
So this is ALMA,
yes,
which is in Chile,
yes,
up in the high mountains there. What was the response from ALMA when you asked for this time? Again, it's quite a difficult thing to ask for time to do.
Yes, I have to admit we'd already asked 3 times and they'd told us to go away and not be silly. But after these 3 rejections, we went back with the new JCMT Discovery Spectrum and asked essentially the director and said, we don't need very much time, please let us have a chance to confirm this. And they were great. They swung around and said, we'll give it a shot.
You see, this is one of the impressive things. I don't think there are many people who would have written the 4th proposal. Plenty you get rejected once and try again.
Never give up, never surrender. That's me in astronomy. So we needed about an hour and a half of ALMA time. And I think we did that in March of 2019. I think it was really about May before they could give us the data. And then I'm not really skilled at this, so my colleague Anita Richards, who's an ALMA support scientist in Manchester, she had to dive into this and like invent whole new computer scripts. So it was about 3 months later that I was able to go up there and say, well, let's just have a look and see if we've got anything. I found this spectrum actually the other day. That's the Discovery one. It was late at night, and you can see the spectrum for that has the classic dip on it.
Yeah, so this is it. This is the signature.
I was sitting, I think, probably locked behind the one-way door in Manchester at that point going, oh, I think we really have got it with both telescopes.
Yeah. So this is the JCMT one?
That's the JCMT one. So that was January 2019 when I was reasonably sure. And that's June of 2019. I'm like, here it is again.
So this is the clean data on the screen. What are we looking at here?
Yep, so this is a JCMT spectrum now cleaned up a bit, so that's these white step boxes. And we've got the ALMA spectrum of the planet as a whole, which is the black line here. So you can see that really they look very like each other. So it was a robust result, 2 telescopes, nothing to do with each other, saw the same thing.
And then you said that the signal does vary as you move around the planet.
Yes, so the really exciting bit is the polar caps of Venus are here and here, And when we took spectra at once the average of the north and south polar caps, there's really nothing there. You can see
the dip's missing
the
completely.
dip is completely missing. And that's the intriguing result about, you would expect if there are organisms circulating in the clouds, they would have to sink where the clouds sink down at the poles, and then they kind of come underneath and come up again nearer the equator. So the spectrum here that we've got is the average of the north and south kind of mid-latitude bands.
And it is really obvious there's something there.
It's really obvious there's something there. So that kind of blew me away.
What about the idea that this could come from something that isn't life?
So this was the next stage. You know what the cycle of doing science is like: optimism, despair, optimism.
Is there life on Venus? That's what I want to know.
The task of ruling out alternative explanations for phosphine in Venus's clouds fell on the shoulders of biochemist and astrobiologist William Baines.
If you wanna find out, that's where you gotta go.
What were your thoughts when you first heard that Jane and her half of the team had found what seemed to be phosphine in Venus's atmosphere?
I was just stunned. I thought that, my thoughts immediately went to biosignature gas, because that's what we've been working on for years back with the MIT group. But on Venus, there's something seriously weird going on there. Perhaps this is life. And that just blew me away. It was so exciting.
You and others in the team started to try and work out other possible ways of getting to this result. What did you consider, and what did you conclude about natural processes, non-living processes?
We thought, could there be a reaction between gases in the atmosphere that would spontaneously produce phosphines? And then you could work out whether that reaction releases energy or consumes energy. And if it consumes energy, then it's unlikely to happen on its own. If it releases energy, then it happens on its own. So we did this for about 75 combinations of different gases in the atmosphere that could produce phosphine in theory, and they all consumed energy, every single one of them. So that's just not going to happen spontaneously.
So then you can maybe make that happen by putting energy in. So this is where UV light comes in. If you're exposed to the sun, you can make reactions happen that way.
Yeah. So what UV light can do is they can take some of those molecules and it can split them into highly energetic, highly reactive components. And then those could react with other things to make phosphine. And so we produced a whole network of possible reactions like that and said, what's the rate at which that chemistry could happen? And that turned out to be about 10,000 times too slow to account for the phosphine we saw. So it could happen, but only in tiny, tiny trace amounts.
And what about volcanoes? Because Venus is a volcanic world. We think there might be live volcanoes there now.
Yeah, so we did the same sort of calculations for reacting phosphorus compounds in the rocks. And again, you need to put energy into the system to make that work at all. And we went round it again. And we just could not come up with any combination of subsurface, on the surface, in the atmosphere, up to the clouds, in the clouds, anything that would explain the presence of phosphine.
In the end, we could show that all of these are like 10,000 times too weak to produce the amount of phosphine that we see.
But there's one final problem for any floating Venusians: acid.
Life needs some sort of solvent, some liquid for the chemistry to work. And the only solvent available appears to be in the clouds, which is sulfuric acid. Sulfuric acid is an incredibly corrosive, aggressive chemical, and it's completely incompatible with the chemistry that we know of life. So there are microbes that live in quite acid environments on Earth, are known, but they are nothing like the clouds of Venus.
So how acidic is the environment in the atmosphere of Venus?
It's something like 1 billion times as acid, and that will just destroy anything that we understand of as biochemistry. Well, I thought I'd illustrate just how hostile to life the environment of Venus is. So we've got some sulfuric acid in the safety hood over there, and what we're going to do is expose some biological materials to it and see what happens. Okay, so let's start out with the classic sugar and sulfuric acid. So this is sugar, and here we have our sulfuric acid.
Wow. So is that just water coming off that?
That's steam coming off. And this is the sulfuric acid chemically breaking down the sugar, pulling water molecules out and leaving an impure form of carbon behind it.
That's amazing.
Okay, so I thought we'd try the same experiment with peas.
In goes the acid, and they're already looking unhealthy.
It's just smashing to pieces. And I did one about an hour ago, this guy here.
Oh wow, that's just not well, is it?
It's just turned to sort of tarry sludge. So no for growing peas on Venus.
So if this is life, we have to imagine a whole new set of biochemical reactions, a whole new way for life to be, really.
Well, there are two ways that it could possibly be life. One, as you say, is there's just a completely different biochemistry there. It's radically different from anything we imagine on Earth. That would be incredibly exciting. The other way, that in principle, a more water-loving life, a bit more like the biochemistry you see on Earth, could hide itself away inside a protective shell of some sort, inside the sulfuric acid droplets. The difficulty with that is, how on earth do you build a shell that's sufficiently tough to withstand that aggressive acid environment and can keep the acid out and the water in?
So we're talking sort of armoured bacteria here.
We're talking bacteria surrounding themselves by something tougher than Teflon and completely sealing themselves in. So then how do they eat? How do they exchange gases? You know, it's a real paradox. But radio said that there's phosphine in those clouds. That's weird chemistry. It's something they're metabolizing and waving back at me. So this is a succulent plant, and in order to protect themselves against water loss, they tend to cover the leaves with a thin, waxy layer that's quite resistant to all sorts of chemical attack and fairly resistant to sulfuric acid.
Okay.
So let's give that a go.
Now I'm expecting this leaf to go black and shrivel.
It just sits there.
Yeah, it's like a raindrop or something.
It is. But it is quite astonishingly resistant. And that does give me hope that of the two mechanisms by which life could survive on Venus, the idea it used sulfuric acid or protected itself from sulfuric acid, that second one is not completely impossible. It could float to the clouds if it didn't float too low.
And so maybe they could live shielded in these little droplets and have some kind of life cycle where they sink, but then they go dormant, and then they carry it along through the atmosphere of Venus, and they come up again, and the conditions are favourable, and they have light and a bit of water again. So they circulate around in the clouds.
It's amazing that you get to there from a spectrum. It shows how a simple experiment, is there phosphine on Venus? It gives you this rich sense of ideas to explore.
Yes, I was really surprised no one had tested this idea of Carl Sagan's very much before, that there could be these floating organisms, because lots of people seem to think it was a nice idea and quote it, but nobody had really made a plan to go out and say, what would you observe? So I thought, this is great, why don't we just have a go?
Is there life on Venus? That's what I want to know.
Let's just talk a bit about the importance of this discovery. Let's say this is life. Why does that matter? Why do we care that there are bacteria in the clouds of Venus?
Well, there's a long-standing question, not just in astronomy, but in humanity, is, are we alone? Yeah. Is there life elsewhere? If life on Venus evolved independently of life on Earth, it was a separate biogenesis, if you like, then that implies that there is life everywhere. And the chance of it having occurred just twice in the entire universe in the same solar system completely independently is, essentially zero. So if it's happened twice, it's happened a bazillion times. And that really increases the chance of finding life or past life on Mars or Europa or Enceladus or planets around other solar systems.
We spend a lot of time talking about habitable planets, places where conditions are like Earth. And okay, you're in the atmosphere of Venus where some of the conditions are a bit like Earth, the temperature and the pressure, but you would have ruled out this planet because of the sulfuric acid. I think it's a shock to the system that if we're looking for alien life, we should look in some alien places.
When we find planets, if we now find an exoplanet and go, this is an exoplanet, it is Earth-like apart from the fact it's got a Venus-like atmosphere, A week ago, the scientific community has said, well, let's forget about that one.
As far as life goes.
As far as life goes, yeah. Now, I don't think people will forget about these planets.
If you wanna find out, that's where you gotta go.
And so what will you do next?
We would like to do some more collaborative work to say if there are microbes, what other molecules would they put out there, and then we can go and do a perfectly sensible search for those. Really hoping somebody who's got more money will come in and say we could start to plan for a space mission to go and deliberately sample the atmosphere of Venus.
Is that what it would take to establish that these are real? You'd have to go and scoop some of the atmosphere up?
I think a fly through the atmosphere would be super exciting, and given they managed to get a lander to the surface and signals out in 1985, that's got to be possible, right?
That's the scientific journey. With any science, there's a sort of emotional journey that goes with this. And we're talking in this strange time, where is it going to be published? How is it for you at the minute in this sort of limbo?
It is very strange, yes. So I did tell my mum. She's very excited about little, she's decided it's not little green men on Mars, so it must be little red blobs on Venus. So she's super excited. But yeah, it's been hard to not tell people.
What do you think the reaction's going to be?
I really have no idea, because I've never set out to do anything like this. So I don't know if people might be a bit like, oh yeah, another of those, life somewhere stories, or more hopefully like really engaged in it, want to go out and observe Venus, naked eye object pre-dawn at the moment, just go out and have a look.
I think some people will say there cannot be life on Venus, and therefore there's something wrong with the result. I think others will say, well, maybe there is life there, but it must be something very strange. And if it's something very strange, that's really exciting, and so we should go there and find out. I don't think it's unfair to say it's the most exciting scientific discovery I've been involved in quite a long career in biochemistry, because it is so inexplicable.
This is the closest we have ever come, and possibly will come for quite some time, to finding life elsewhere.
And do you think it's life?
I am worried by this business about the clouds are almost entirely sulfuric acid. So if it turns out there's some kind of crazy chemical reaction going on that just wouldn't happen on the Earth, I'll be a bit disappointed, but I'll know we took part in a really important search, and we've done something super unexpected for the atmosphere of Venus. I'm obviously really hoping that this whole story that bacteria could have floated up to the clouds, that could actually be it. Yeah.
We're talking like this is a normal scientific result. If this turns into what you think it might be, this is one of those world-changing moments. Do you think about that?
I mean, it's a lifetime-changing moment for me to have participated in something so exciting. If it's a world-changing moment, I kind of struggle with that, but the whole process has just been total excitement. But yeah, the implications are a little bit overwhelming.
Well, Jane, thank you so much for talking to us.
Thank you, always a pleasure.
While Chris has been catching up on the breathtaking events in Cardiff, Pete has been staring across the length and breadth of our solar system, including his first views of Venus with added life. You can watch that on our website at bbc.co.uk/sky-at-night.
Isaac Asimov said that the most exciting words in science aren't "Eureka, I've got it," but rather, "That's odd." And the team here in Cardiff have certainly found something odd. It's been so exciting to talk to them about it, and to hear how excited they are about sharing the story with the world. Do we understand the chemistry of Venus's atmosphere well enough to say that this is definitely a sign of life? No, not yet. But could the story of our discovery of life on another world, the moment when we know that life exists beyond Earth, start like this? Absolutely. Good night.
Go back in time to experience the gamut of emotions that raged through two extraordinary Apollo missions, Apollo 11 and Apollo 13. 13 minutes to the moon. Download BBC Sounds now. Next, we stay looking up with Horizon.
Bye.